Great. Hello, everyone. Thank you very much for being here. I'm Filip, one of the co-founders of SpaceComputer. And today I'll be talking about our vision and direction, actually some solutions we already have in the workings that hopefully can solve some of the challenges that we are that we see already on Earth infrastructure, and hopefully we can do something better when moving and building a new infrastructure of the future in space. And while waiting, it's definitely interesting to see how the technology is making a lot of steps. And I'm actually missing on this slide one technology which is called trusted execution environments, which is actually something I'll be talking about. And it's a great segue for starting the talk of mine. And we definitely see a lot of interesting possibilities on how to improve on the threat model of trusted execution environments themselves. So. Now the slide, yes. Yeah, definitely being also like having a footprint in Europe is definitely great to see the initiative of trying to make Europe great again. And hopefully, especially being based in Germany, I can relate to what Lucas was mentioning regarding the bureaucratic overhead of dealing with businesses. And hopefully there'll be a way of making it easier in the future. So far, I think we are not there yet, but at least some form of digitalization is happening. I think the Munich ecosystem is thriving, like with respect to Web3, which is great. I think we have a very good student club that started roughly 3 or 4 years ago that is very, very active. And it's actually great that also our research group is part of it, so we are actively supporting them along the way. Many of the students went through our chair with respect to thesis advising and so on, and they are later on landing jobs in the Web3. So it's definitely great to see, and we hope to keep it up. Maybe a short advertisement as well. We will be organizing a small event called TUM Blockchain and Cybersecurity Saloon in June, so hope to see you around there as well. But great. Now, since the slides are there and are working, let me unfold what have I prepared for you for today. So the title is quite long, but hopefully along the way of the talk itself, we can unfold some of the components. So let's start firstly with the end of the title, which is Space Data Centers. Out of curiosity, who of you has heard about the Space Data Center in the past months, weeks? Perfect. So it might not be as new to all of you, but the new meta that is happening and brewing in space is that we start to see that there is a lot of activities regarding sending general purpose compute in large scale to space. Companies like Google, SpaceX, also like startups like StarCloud actually very heavily pushing on the direction of leveraging the free resource with respect to the solar energy, and also free cooling once you manage to disseminate the heat, and basically start to build and ship these massive compute centers running in space. I think there is still a lot of technical challenges ahead of it, but I don't want to be jumping into it. But of course, happy to take your questions afterwards. But in general, what we see with respect to the trend is that space is open for business like never before, which is exactly where we are very happy that as a SpaceComputer project is rather young. We started roughly 1.5 years ago, are actively building on the technology that can enable many of the use cases we envision for the future. And of course, unlocking aspects of space being open for business is mainly due to the fact that companies like SpaceX are actively pushing on making the cost per kilogram of launch cheaper and cheaper. So currently, we are talking about thousands of dollars per kilogram, but of course, moving forward, especially once there will be Starship or other technical solutions, we'll be talking about tens of dollars per kilogram that you have to send up to the LEO orbit or others, which of course makes it much more open for launching your own solutions. And of course, the more funding is also being poured into the capital, the more commercial off-the-shelf solutions will be available, making the cost even lower. Providing also a brief overview on actually how space operates with respect to current setting is we have big launch providers like SpaceX that is of course building their Starship. Many of you have also heard about Blue Origin, where the general idea is to really build big rockets that can be reused for sending as much payload to the space itself. Once you are actually able to do it, you can start to, of course, think of building large infrastructure in space. So you can think of something like International Space Station, but of course meant not only and operated by public sector, but by private sector. And we start to see companies like Wasp Space, Axiom Space actually aim to build their new alternatives to international space stations to provide a cool infrastructure where you can experiment and actually enable new type of life, let's say, depending on what is the motivation of some of the companies. But of course, to also enable it to general purpose solutions, there are rideshare companies that in case you don't want to necessarily build and launch your own stuff, you can actually share the payload space that is enabled by the others. So we have companies like Rocket Lab. Of course, SpaceX is also offering the SpaceX rideshare, which in general aim to provide lower the cost barrier for basically sharing stuff and sending things to space. And of course, some of you maybe already are using solutions like Starlink or Kuiper, or also some European solutions that in general meant to provide connectivity in a high speed in a global fashion with as many satellites as possible to enable low latency and high throughput networks as well. And of course, the part that is currently being developed in many solutions is the application and compute layer, where especially the data center fit into the picture to make sure that you can actually leverage all of the capabilities and infrastructure that is being shipped all the way to space. And what we see that security will play, or already plays as of now, a crucial role in many of these applications. So you can think of it that if I want to communicate with the satellite itself, of course I want to make sure that the data are encrypted and secured. And definitely there'll be more and more stuff sent for edge computing, either in the local environments where the infrastructure is not so strong. So you can actually envision this part will become much more prominent. Eventually, once you start to rely on third-party infrastructure, you also want to make sure that you are protecting the sensitive information that will be run on this infrastructure, either for algorithms regarding AI, storing keys, and many others, where of course you will require this type of sensitive computation to be in place and make sure you can actually convince the others that they don't have access to it. And finally, once we actually see the transition, we will no longer only consider focusing on Earth users and applications, but we'll start to develop some interesting space-native applications. I think quite a few topics that made me really excited is, for example, we talked about it with a few people in the audience during yesterday. Debris start to be a very large problem, and there start to be actually a lot of logic and investment happening in the direction of running your sensitive proprietary algorithms on satellites in space to detect the debris and find the optimal path in space as well. So of course, this is like an example of one space-native application, but more and more will be popping up in the future as well. So working in the area for quite some time, let's also try to revisit what is the state of space itself. So we definitely see that the future is bright. In 10 years, we definitely see that inter-satellite communication using Starlink or other type of solutions with high throughput, low latency anywhere in the world will be possible. But are we there yet? And definitely we see that it will take definitely some time. But of course, with more interest, more funding being put into the industry, many of these solutions will become no longer a problem, but will enable new type of solutions being built and applications relying on them. So as of now, we see a lot of challenges regarding compute, meaning you are constraints on the power front. You cannot just like launch any type of arbitrary server because just the power capacity is not there. You have to also cool it, which is of course challenging by itself as well, because you in general need to also find a way on how to disseminate the heat to space. And the aspect is also communication, because if you want to be sending gigabytes or terabytes of data on a regular basis, you need to also have the power to actually be powering the antennas that will be transmitting this type of data. So as of now, we are not there yet in a general purpose, but definitely we see that potential is there. And fun statistics, talking about privacy, around 50% of current traffic that is being exchanged among satellites is actually not even having a basic encryption enabled. So we see there is actually a lot of space on how to improve the general state-of-the-art solutions moving forward, which is, I think, very exciting from my point of view, because when I was very young, I couldn't contribute to building of the internet in many aspects, but we see that the patterns that actually are working very well on Earth can be actually moved also to the space-based infrastructure as well. So what we have been building for the past year is like really getting the understanding of the space and following the motto that crawl before you walk and walk before you run, because we want to really set up good foundations moving forward as well. What makes us very exciting is the aspect of unique properties provided by space, where the important one from our point of view is the physical isolation, meaning that it's beyond borders, it's beyond reach, and it's very much immune to physical tampering, unless you manage to really catch the satellite in the flight, which is quite challenging in the orbit. And it can provide a very ultimate tamper-proof and censorship layer moving forward as well. Which brings me to the second point of the title, which is the trusted execution. For those that are not so much familiar, just to do a quick rundown of TEEs, Trusted Execution Environments. You can think of them like an isolated region in a CPU that aims to provide you additional instructions to the users that are developing and using this type of applications building on top of that, where you can actually run your sensitive code and data in a seamless fashion. And you are getting confidentiality and integrity of the data that you are computing on. And what is, I think, most exciting and fitting the Web3 applications is that you can actually convince others as well that the computation has happened inside, and it provides this attestation capabilities that actually others have a confidence that the computation is verifiable as well. As of now, there are several solutions for both categories, either process-based or VM-based solutions from Intel, AMD, ARM, that in general rely on the hardware root of trust. But they are facing several challenges, especially in the recent years, because as a part of their threat model, they do not consider physical attacks, meaning that actually there is some reliance on the host, the operator of the infrastructure, where the general threat model is a running meme in the industry is that you require the guy with a Glock, who is basically standing in front of the data center itself to make sure that it stays protected and not physically tampered with. And it's basically where we see a lot of recent tweets, especially for those that are following TEs. There was a lot of exploits happening in the past half a year that, of course, in general, if you look at the discussions between TEs or purely cryptographic solutions, are sparking a lot of interest on Twitter. And it's in general interesting how the evolution of the discussion is coming up. And I think it's actually great that many of these attacks are popping up because it makes it better, and people can later on focus on making the solutions of TEs better as well, which I think is definitely relevant as well. And this was like one of the initial ideas that actually we started to work on, which is just, okay, if we send stuff to space, we can actually have this physical isolation for free, right? Because you are basically running your infrastructure in space, and you have this perfectly air-gapped environment where you can actually run your execution, which is correct. But of course, we see it hitting its limitations in some aspect. Because if you especially consider Web3 like infrastructure where you don't want to run and trust the operator, you have to also find a way on actually how you, for example, protect yourself against a possibly malicious operator that is owning the infrastructure as well. Which brings me to the last point, which is Space Fabric. We envision to provide Space Fabric combination, which is leveraging the aspect of the physical isolation, but can actually also have additional trust assumptions with respect to the hardware we'll be launching. And in general, we want to secure not only, for example, the guest operating system, but also have a look on what we can do on the securing of the host operating system as well for the aspect of efficiency, but also minimizing, in general, the trusted compute base. So we are looking into the aspects of also running the user's application in such an environment that actually can provide very much small verifiable footprint with respect to the logic they are running. Which also is something that actually we have been working on in the past as well, and start to see the trend for TEs as well, that you want to have the execution assurance where actually your compute is happening. And of course, we have to also convince others that the computation is actually happening on a satellite and not in someone else's basement on Earth. And for that, we are also having a design of a protocol that is aiming to provide this satellite execution assurance itself, which hopefully can be used in the future for other applications. And in general, of course, we are following the part that not every compute has to happen in a TE, but we want to identify the sensitive computation and offload them to the TE, or in some setting also into HSM, when especially you don't necessarily care about the remote attestation capabilities themselves. But if you care, we of course want to make sure that actually you can verify this has happened as well. We are working on a white paper that will be outlining all of the threat model aspects and outlining all of the details of the architecture, so please stay tuned. It's not there yet. And more importantly, the architecture design we are actually now leveraging will be part of our following launches in 2026, where each of the satellites will be equipped with this unique combination of hardware and software. And basically, we can later on offer and build applications on top of it. So kind of looking into the overall picture, we are envisioning that Space Fabric will be the next generation of the hardware in combination with software, of course, and the physical isolation that can provide very unique type of applications to the user. Where we are with respect to use cases, outlining the challenges I mentioned before, we don't have necessarily the high throughput, we don't have necessarily the heavy compute capabilities, but definitely if you look into aspects like key management service with robust key store, backup solutions is definitely there. Something that actually we are already offering with a single satellite we have in the space is getting actually strong randomness from space, the random number generator itself, that you can actually use in your applications. And Definitely something interesting also for other solutions out there. In general, we want to provide like a checkpointing, bulletin board capabilities. So if you have a state update that you just want to make sure, okay, in case there is some part of like a long-range attack or a doomsday scenario, we want to make sure that actually you can store these updates on our solution that we are providing. And in general, we want to provide programmability in a confidential manner, relying on confidential smart contracts as well. Which of course means that in case we are not operating everything by ourselves, but we also open it to public because we want to build an open public infrastructure for others, it means that we have to also consider Byzantine fault tolerance, which means that we want to run a constellation of satellites that will be running layer 1 capabilities, meaning basically a consensus and all of the aspects that come with it to make sure that the synchronous state among the peers is ensured, and each satellite can serve as a validator as well. So overall, the compute that we want to provide should be trusted and verifiable by others that actually will be leveraging this type of technology as well. From the perspective of user journey and how they will interact with it, of course, we want to make it as seamless as possible, even though there will be quite some challenges along the way. And the way how we currently envision it is like something that we already see in the Web3 space is like having RPC endpoint, or that will be actually running in a trusted execution environment by default, because we want to use the same infrastructure for both the layer 1 capabilities, but also for the security services that I was talking about. Where user on Earth can communicate with this infrastructure we call Orbit Port, that will be later on forwarding the services to space. But of course, looking forward, the plan will be to make it as open as possible so others can also run this infrastructure piece. And in general, the gateway that we will be relying on should provide trustless gateway for space communication, providing end-to-end confidentiality between the user and the infrastructure itself. And of course, we want to make sure that the data can be protected along the way as well. So we definitely see that this could be something beyond Web3, but can be actually a general pattern that we are also in touch with space companies that might be leveraging this technology as well. As of now, it's rather centralized. It's basically operated by us. We have to bootstrap somewhere. But of course, moving forward, we want to make it more and more distributed and decentralized by having the capabilities of others being able to verify it by running it in a TE on Earth, and make sure that actually we find interesting partners that can actually operate this piece of infrastructure as well. And moving forward, we of course envision that other people should be able to communicate and run this piece of software as well, and be able to communicate with our infrastructure directly. So you can think of it, the ultimate goal is everyone has their own Starlink dish, and they'll be able to communicate with our endpoints in the space directly. But of course, it will take some time before we get there. But in general, actually something that already people can play around with as of now to get a bit of a feeling on how is it to interact with space infrastructure. We already are providing one use case called CTRNG, is the Cosmic Random Number Generator, where as a user, you can directly request either the API, through API, the randomness from space, be able to consume it for your applications, or in general, just like rely on us forwarding it to you. And something that we are actually very excited about is that public randomness has been enabled already in the past, but we are working also on private randomness, meaning actually that the private beacons will be able to consume for your sensitive application, which I think is very exciting because it unlocks many use cases and application where you can fetch strong randomness through a random number generator and use it maybe for consensus, but for respect for the leader election process or other cryptographic protocols that in general require this type of randomness as well. So if you're interested, happy to catch up afterwards. So overall, we envision that the application and compute layer is the next aspect of the frontier of space intersection that will be providing communication between Earth and space. And definitely, as a space computer, we want to be part of that and make sure that actually we can provide confidential compute layer that can be used by users on Earth, but also in space, and make sure that the data centers of the future can be secured by our technology as well. We have a busy year ahead of us, so it's really great to be here at the beginning of 2026. Let's see next year how many of these aspects will be achieved. Hopefully as many as possible, but definitely something that is a work in progress is the white paper regarding that we call Space Fabric, which is the initial step that we want to describe how a single satellite should look like and what is the threat model that we envision with respect to space, but also providing the capabilities such as the satellite execution assurance. Afterwards, we are already working now with few partners regarding the key management solution that will be providing the mix of on-Earth and space infrastructure. We'll be launching a few satellites, so it's also very exciting to see how they will be shoot up to the space on Falcon 9. And hopefully we can also run a DevNet that will be combining the aspects of consensus and execution, and of course build up the momentum afterwards towards the constellation as well. So if you have any questions and want to play around, we already have a couple of recipes that you can play around, just try to make a small demo, and feel free to reach out. Thank you very much.
Any questions from the audience? Oh.
Hello, I really enjoyed the talk. So imagine if I put a machine in space and like RAM goes down, is it going to be possible to replace it, or I don't know, address that concern?
Yeah, definitely. It's on our like day-to-day basis. It's a little bit hard. It's providing a good feature that you cannot like really physically tamper with it, but it also means it's very hard to maintain it. So on that part, we also a little bit had to change the model, and we are trying to provide crash fault tolerance within each satellite as well, which basically means we have redundancy. So we have usually multiple same kits of the same hardware, basically, where we also try to duplicate as many of the sensitive compute itself, but also the sensitive information we stored across different kits on the same satellite. Sorry? Exactly. It's basically multiple redundancies on the same satellite itself. So that way, we are still kind of looking into the design. There is a space for improvement. We are currently in the V1 of the hardware, but basically, as of now, it's not even like a hot swap. You basically kill one solution and you migrate into the other one. But of course, moving forward, like we want to make sure that there is some logic that we can do, and you can do, fortunately, also a lot of things in software. So you can be regularly checking that there was no bit flips and others. And also, since we are operating in LEO constellation, it's less aggressive environment with respect to radiation and others. So it's also the good place to start with. But of course, if you, for example, consider geo constellation, of course, then it's like much closer, much farther from the space atmosphere. So you will have much more requirements for hardening the hardware as well regarding radiation and others. Yeah. Okay.
Any other questions before we move on? Oh.
I'm just wondering, given how fast all the compute power is developing in the world, like what is going to be the useful life of whatever equipment you send into space? Like how long does it take for that hardware to become obsolete or not fast enough anymore?
Yeah, a great question. So on that part, like I think this is the more question to the space data center guys. I'm a little bit skeptical as well to like really compare like, okay, you know, the classical east zone of GCP and the performance that you get, and comparing it to let's say the space data center itself, because the hardware definitely will depreciate much faster as well with respect to that. But I think on the front of finding the good balance, I think if you really try to lower the cost as much as possible on the front of shipping the stuff to space, and actually really try to see on how much energy you spend for cooling it and powering it, I think there could be like an interesting intersection. But at least when looking into the initial numbers, it doesn't pay off yet. But of course, if there is an interest and more funding is put into it, I think there is many interesting engineering solutions that can be solved to make it more viable solution. So it's going to be exciting. I know that, for example, Microsoft has in the past also experimented with putting data centers in ocean. There's basically made like basically a submarine in some way that they put into the ocean for cooling. And it was quite a viable project, actually. It worked out, and I think now they are considering to rolling out in bigger scale. And it's the same story, right? Of course, you can go and swim to the data center that is like in ocean, but you don't want to maintain it on a regular basis. So it will be interesting what basically becomes more convenient solution for them. But in general, if you look at the timeline of the time span of the hardware, it's somewhere between 5 to 10 years, depending on how much you want to invest into the satellite itself, because it can have additional engines to always basically keep you in a specific orbit, because by default it's always decaying and eventually burning up in the atmosphere. And if you look at the data centers, I think actually they are changing the hardware in a similar time frame as well, or they're even reselling it to other providers that are still actually keeping it up and kicking. So I can imagine that the years will not become the problem, but rather actually will become the compute that you are getting out of the hardware, because the efficiency and more slow. Yeah.
All right. Thank you so much. Big round of applause for Filip.
Thank you.
Thank you.